Welcome to 4.1 Part 2. If you haven't seen Part 1 yet, there's some formula information given on there that will be pertinent, but we'll try to review what we need for this. Okay, let's pick it up. In exercise 47 through 50, we're to rewrite the angle in radian measure. So what we know is that pi radians is equal to 180 degrees. Therefore, pi on 180 degrees equals 1, and so does 180 degrees on pi radians. So we can multiply anything by 1 in this form or that form to change unit measure. So you might have done things like this in chemistry quite a bit. I'm going to put this negative 270 degrees on 1, and if I want to change to radians, I need to introduce radians while canceling degrees. I want to use this option. So times pi on 180 degrees. And we could do this with calculator and take negative 270 divided by negative 180 and do a math fraction, but this simplifies pretty easily. Cross cancel the zeros, 27 and 18 reduced by 9 to negative 3/2 pi. Okay, maybe a little bit more computational challenge here, but same process. I want to cancel degrees. That will cancel degrees. I want to introduce radians. So this will cancel nicely, but I want to show you this on your calculator. So I can clear this guy and have to do a little refocusing here. I'll be refocusing quite a bit on this so we can see both my calculator and the screen. So anyway, we've got 144 times pi, which is second caret, which is right above the division sign, divided by 180, and we would get, this is a decimal. Now if we try to math fraction that, we may have some challenge with that. However, if we leave pi in our answer like we did the last one, let's try this. 144 just divided by 180, and I get 0.8, which of course is 8/10 or 4/5, but you could math fraction, and we get 4/5. So we end up with 4/5, and we still have to multiply pi in. And yes, pi can be above or below, or it can be up with the 4, like they do, and as you can see in number 54. But I like putting it afterwards because I like just saying 4/5 pi instead of 4 pi over 5. It's just a personal issue. Okay, and then likewise in number 54, 51 through 54, we're to convert to degrees, so we want to cancel radians. So I'm going to multiply by on pi, cancel radians, and introduce degrees. And again, you can do this, obviously the pi's cancel here, and then the 6 and the, you could do this calculator, but the pi's cancel, the 6 and the 180 reduce nicely to 30, and I get negative 15 times 30 degrees, or negative 450 degrees. Okay, when you have a pi included and you want to change to degrees, you could, as simple as this, as we can see on the last problem, if there's a pi in there, we can cancel and we can just replace, basically it looks like I'm replacing pi with 180, which kind of makes sense because pi degrees is 100 radians. You could just do this like this, 28 times 180 degrees on 15. And again, this could be a very, very easy, lot of canceling going on. I'm happy to do that with you, but I'm going to go ahead and just go through this on calculator. We're going to go 28. Let's get a little bit better look at this. One more time, try to get a little bit better look at this. So we'll just go, in that much time I could have just done it by hand, 28 times 180 divided by 15. And we get 336 degrees. Try one more time here. So you're just going to have to bear with me as I switch back and forth off calculator. Okay, in 55 through 60, convert the angle measure from degrees to radians. So I want to cancel degrees. So I create a fraction. To cancel degrees, I want my degree equivalent in the bottom and my radian equivalent in the top. I'm really just multiplying by 1. And since we're rounding to 3 decimal places, we're going to go ahead and use our pi value rather than 3.14, because if I put in 3.14, I'm going to be multiplying that error, dividing, who knows what kind of error I'm going to end up with. So, once again, we've got negative, boy, it's easy to forget the negative on these, 46.52. Yes. Sorry about that brief interruption. Had a visitor. So negative 46.52 times pi and divided by 180. And I get negative 0.812 radians. And lots of little pauses here as I go back and forth. Okay, convert the angle measure from radians to degrees. Round your answer 3 decimal places. So I'm going to just tell you I'm going to be doing this on calculator, but we need to convert to degrees. Therefore, I want degrees to be introduced, but I want to cancel radians. These cancel, and I end up with, I'm just going to do this off to the side, 5 times 180 divided by 11. Straight calculator here, and I get 81.818 degrees. And when there's a decimal and no pi, I'll have people that at times think, well, that must be a degree measure. There's no pi. We can have radian measures without degrees, as we learned on part 1. So, same deal. I want to introduce degrees, and I want to cancel radians, so I multiply by 1. Again, I'm going to do that off to the side. Negative 0.57 times 180 divided by pi. And we should come up with negative 32.659. So you might want to play along for the rest of this video with your calculator just to verify this is degree measure. And this may be new for us this year. This would be read negative 408 degrees, 16 minutes, 25 seconds. And this is used in longitude and latitude quite a bit. It may be a little antiquated, but it's so locked in. It's kind of like America using the English foot, pounds, miles system, not jumping into to what the rest of the world is doing and with the metric system. But if we want this as a decimal, we could go negative 408 degrees. This is minutes, so this would be 16/60ths. And this is seconds, and how many seconds are in a full hour? It's the same, 3,600. There's 60 seconds in a minute, 60 minutes in a degree. So this would be plus 25 on 3,600. And then we can go ahead and get that on calculator. I'm going to do that real quickly. Negative 408 plus 16 divided by 60 plus 25 divided by 3,600. And I get, I needed that to be minus, just a second enter. Quick entry error there. Delete and enter. Okay, equals 408. So careful if you're doing this. This should really be plus negative here, because we're going to be beyond 408 negative degrees. So we end up with 408 but negative 0.274. But I want to show you that your calculator will actually do that for you, and this is pretty slick. So I'm going to enter negative 408, and I'm going to put a degree symbol after that with second angle here, second apps is angle. So I've got second apps go to angle. There's a degree symbol. Then I'm going to go 16 back to angle, second apps. There's my minutes. While we're here, notice they don't have any double of these for seconds. Talk about that in just a moment. So we might think go in there and add 2 of these, just do that twice, but we're not going to. Down on the memory key or the plus key, alpha plus gets us the little quotation marks. So I'm going to go second, or alpha, excuse me, plus, there's my quotations. When I hit enter there, I end up with my same value that I got before. Okay? All right. Now, this one, we are to find the difference between these two angles. And we can actually set this up in our calculator as we did right here and treat that and just put a subtraction between those. And that's probably a good idea, because imagine this. Let's say that this was 35 seconds here. Now I've got to borrow to cover that 29, and I would borrow 1 minute here, and that's actually adding 60 seconds on. We used to have to do that, but since I don't have to borrow, it's really this easy. Minus 12 degrees, 36 minutes, I have enough minutes, and minus 3 seconds, I have enough seconds. So let's see, I get 29 seconds minus 3 seconds, 26 seconds, 45 minus 36, 9 minutes, and 120 minus 12, 108. But again, you could just enter this in your calculator using the angle option and then put minus, and it would give it to you. It would give it to you in decimal form. And then you would convert that to degrees, minutes, seconds, which I'm going to show you how to do in this next problem. So converting to degrees, minutes, seconds, use the angle conversion capabilities. So I'm going to, let me see this because this is new for us, I believe. Okay, I'm going to go 490.75. And I'm going to go into angle, second apps. There we are. And there's convert to DMS. That easy. 490 and 45, not point, 490 degrees and 45 minutes. Well, we could have done that because 0.75 is 3/4 of 1. And on this clock unit we're using, 3/4 of the way around the clock is 45 minutes. But this one might be a little bit messier. Now, this one, notice, no degree symbol. So I need to convert that to degrees first. So I'm just going to go, let's try this again. I'm going to take that 0.7865. I want to introduce degrees, so times 180. I want to cancel radians, divided by pi, and I get this. So there's 45 degrees, and now I'm ready to convert to degrees, minutes, seconds. If I just did it on the 0.7865 that we had here, the calculator is going to assume that we're giving them a degree measure. So second angle DMS, and there's my degrees, minutes, seconds. So we get 45 degrees, 3 minutes, and I'm going to say 47. They have 47.27. I'm just going to say 47 seconds, rounds to 47 seconds. Okay. You could put the 0.27 in there. Generally, we stop at that point. Okay. In the next exercise, find the complement and supplement. And let's see, I think I might be able to get away with this. Okay, all this zooming. So just a reminder, complementary angles, the sum is 90. Supplement, in addition to supplement, the sum is 180 degrees. So 87 degrees, simple, the complement is 90 degrees minus 87 degrees, or 3 degrees. And the supplement is 180 degrees minus 87 degrees, or 93 degrees. Now, 12/5 pi in radian land, the complement would add up to be pi on 2, and the supplement would add up to be pi, 180. So our complement, I need pi on 2 minus 12/5. 12/5 pi, there is no complement to that. 12/5 pi is in fact more than pi. This would give me a negative answer. And supplement, I need pi minus 12/5 pi. There's no supplement either, because my answer's already above pi. So none and none. But that's the process we would use to find it if one actually exists. That's why they have an if possible here. Okay, moving on here. Find the radian measure of the central angle. Okay, as we talked about on the first part, if I've got a circle here, and the radius is 22, I'm not really going to worry about trying to draw this too much to scale, and the arc length here that's intercepted is 10, and we've got an angle theta in here. Find the radian measure of the central angle. We're looking for the measure of theta. Well, an arc length, S, is a fraction of the circumference. And if you memorize the formulas, more power to you. But you may go back to this. Arc length is a fraction of circumference, 2 pi r. What fraction are we talking about? Theta out of 360 degrees. But better yet, theta out of 2 pi. So the 2 pi's cancel, and there's a workable formula. The arc length equals theta times the radius. And that goes back to the definition of a radian, but workable from things that we knew before. Therefore, if the radius is 22 and the arc length is 10, then theta equals 10 divided by 22. Find the radian measure. Here's the good news on this one, but it's worth remembering. Because we canceled the 2 pi's, we're dealing in radian measure. This is the radian measure right here, 5/11 radians. If we use that formula for degrees, we have to get down to here and then convert that into degrees. Okay, so moving forward, we're going to remember that S is theta r. Find the length of the arc on a circle, radius r, intercepted by central angle. So find the length of the arc on a circle of radius r, intercepted by central angle. So we have radius r we'll say this is theta here, and this is 9, but theta is pi on 3. Oh, I'm wrong, excuse me. This is r. I think we have an r equals in the column, and I've chopped this together. So this is 9. We're looking for S, and we've got an angle of pi on 3. I didn't try to draw it to scale, but it's not too bad. It's not too far off. So S equals theta r. S we don't know, theta we do know, pi on 3, r we do know, 9. So I'm just going to jump to my calculator, calculate this, or we could just say it is 3 pi. It doesn't ask us to, because 9 and 3 reduce, it doesn't ask us to round, so I think I'll just leave it as 3 pi. Seems somewhat reasonable, because 3 pi would be equal to 3 times approximately 3.14 would be a little bit more than 9. And at a 60-degree angle, yeah, that seems reasonable. Because at a 60-degree angle, this value right here would be 9 because we'd be in a 60, 60, 60 equilateral. So I feel pretty good about that. Okay, find, and once again, S equals theta r is our friend here. Find the radius r of a circle with an arc length S and central angle theta. See if I can get a better focus on this a little bit maybe. So we have an arc length S, that's 3, equals 4 pi on 3 times r. Therefore, r equals, it started out as 3. To get away from r, I'd have to multiply this 3, and I'd have to divide by 4 pi. So we end up with 9 on 4 pi. There's r. Doesn't ask us to round, so I'm going to leave it at that. So now we've got degree measures, and that presents a little bit more of a challenge for us. So we've got 8 inches. Once again, I'm going to write down S equals theta r. We have an arc length of 8. We have theta is 330 degrees r, but this needs to be in radians to use this formula. So 330 degrees on 1, cancel degrees, introduce radians, zeros cancel, reduce by 3, and I get 11 on 6 pi for 330 degrees. And we could march around the unit circle and find that, or march around a circle and find that. But anyway, times r equals 8. We should be able to set this up right now. R equals, it was 8. To get 6 away, we have to multiply. To get 11 away, we have to divide. And to get pi away, we have to divide. So we end up with r is 48 on 11 pi. I wouldn't be surprised if back of the answer, excuse me, back of the book, sorry about that. Let me go through that since it wasn't on the screen. To get 6 away from r, we have to multiply. 11 away from r, we have to divide. And pi away from r, we have to divide. And we end up with 48 on 11 pi. And I was about to say, I suspect the answer key in the back of the book might have that as a decimal approximation. And finally, find the distance between the cities. Assume the Earth is a sphere of radius 4,000. Bad circle. Radius 4,000. And the cities are on the same longitude. One's directly north of the other. So Seattle, I'm definitely not going to try to draw this to scale. Seattle and San Francisco are both north of the equator. This angle right here would be the smaller of the two, San Francisco. I'm just going to call this theta. And this big angle here from the equator, this is how many degrees north of the equator we are. I'm going to call it, whatever that Greek letter is, I like to call it fish. So what I'd be really interested in is this angle between the two. I'll call theta. Nope, can't call that one theta. I'll call it alpha. We'll call it A. We're really interested in angle A. Here's San Francisco. Here's Seattle. I'd like to know the angle measure between those. So A just equals the difference of these. So angle A equals the big angle fish minus theta, or 47 degrees, 37 minutes, 18 seconds minus, I'm subtracting from that, 37 degrees, 47 minutes, 36 seconds. And if I go to subtract those guys right now, then I would have to do some borrowing. So I think I'm going to do this calculator. I wanted to show you that anyway. So let's go ahead and go back here. Take a look at both of this at the same time. And we still have another step after that. I think that's pretty good. We'll lock that in. So here we go, 47 angle degrees, 37 second angle minutes, 18 second, nope, alpha plus, then minus 37 angle degrees, 47 angle minutes, and 36 alpha plus seconds, and we get this value, which I'm going to just jot down here. That is the degree measure. In fact, that's our degree measure right now. If I'm going to go back and use the formula that we've been using, that the S equals theta R, I want that as a radian measure. So radian measures, I'm going to go second angle, and I'm going to turn degrees into radians, and I should have an option to do that, but I don't. Interesting. Second quit. So I'm going to take that answer and I'm going to multiply it by, I want to introduce radians, because that's a degree measure right now. We were working in degrees. I want to introduce radians. Delete that. And divide away degrees. So we have 0.171536. We got all of that in there, approximately 0.1715. Okay, and now I'm going to go ahead and I'm going to figure out the arc length here. So our arc length, as we saw up above, S equals theta R. See, here's the deal. Theta has to be a radian measure to use this. So our arc length, S equals theta 0.1715 times my radius, 4,000. Now here's a nice calculator trick for you. We already have this value in our calculator. Already got it in our calculator. So instead of using my rounded 0.1715, I'm just going to go ahead and hit times, and it pulls that answer forward. You guys probably know that. Times 4,000, and we get 686.147 miles. And I'm trying to brighten that up a little bit. So how far are they apart? On the curved Earth surface, the arc length is 686.147 miles. So there you have it. Here's your assignment. A lot of quick problems, but a couple you're going to have to think about along the ways. One of the biggest keys that we tried to stress here on this one is this. This formula right here is definitely a radians formula for theta. You do not want to use degrees in that. You'll get false answers. That's one of the beautiful things about radian measures. It has a direct correlation to the length of a part of an arc. Okay, good luck, and let me know if I can help.